Polaris. Polaris movement in space is so negligible that you can consider it to lie in the same position as the North Pole in the celestial sphere. This makes it unique, and you can use this for calculating your position. If you can observe Polaris altitude at any given time, the altitude corrected for errors will directly give you latitude. This observation, along with another position line, or transferred to a later time as done in a running fix, gives you a position fix. First, the longitude in time is added or subtracted to the LMT to get the approximate GMT. Then, the chronometer error is applied to get the correct GMT. Now, GHA Aries is obtained for the correct GMT. Add or subtract longitude to get the LHA Aries. Now apply the index error to the sextant angle to get the apparent altitude. Now apply the appropriate total correction to the apparent altitude to get the true altitude. Now enter the Polaris correction table in the almanac with the LHA to get the AO correction. Now enter the table in the same column with the latitude to get the A1 correction. Enter the same table again in the same column with month of observation to get the A2 correction. Now, if you add the true altitude with A0, A1, A2 and subtract 1 degree from the sum, we get the latitude of the observer. Now enter the same table in the same column with latitude to get the azimuth at the time of observation. Add and subtract 90 degrees from the azimuth to get the position line. Now compare the compass bearing with the azimuth to get the compass error. Add or subtract variation from the compass error to get the deviation of the compass at the time of observation.